Hi guys, welcome back to Beginner-Techies. In this video, I'm going to discuss about three-sum problem. And this is most frequently asked question in coding interviews. So let us first understand the problem statement, then we can discuss about the approaches. Okay. So here we have an integer array nums, and we have to return all the triplets such that their sum should be equal to 0. So in the array, we have to find out the three number and their sum should be equal to 0, such that I should not equal to j, I should not equal to k, and j should not equal to k. So each triplet should be unique. We should not have any duplicate triplets here. Okay. So this is problem statement. Let's see the examples here. The example is given array -1 0 1 2 -1 -4, and the output is the first triplet is -1 -1 2. Second triplet is -1 0 1, right? So if we add these three number, so we will get sum is equal to 0, right? -1 -1 plus 2, we will get 0. Here in this case we will get 0. So this is our expected output. Here we have another example. So nums is equal to 0 0 0. If we sum up these three numbers, we'll get 0. Then output will be this triplet only. Let's see the constraints. So these are the constraints we have. Okay, so let's discuss about the approaches first. Okay, let me add the example over here. We have this example, right? -1 0 1 2 -1 -4, and yeah, so we need to find out the triplets such that their sum should be equal to 0. So in that case the target is 0, right? So what could be the possible approach? So first we can think about the brute force, right? So in this case the complexity would be what? So we have to iterate 3 loops, right? These 3 loop will be used, and in this case we will get a of I, a of j plus a of k, right? If it is equal to 0, then what? Then we have to calculate triplets. So in this case, if we see these 3 loops, we will have n cube, right? Complexity. And if we are going to handle the uniqueness of these triplets, so if I'm let's suppose if we are using set data structure. So in that case, if we are adding element into sets, then in that case we will get complexity is log n. So for this brute force approach, we have the complexity is n cube log n, right? So this is not an optimized approach. So what could be the possible optimized approach? So brute force is not an optimal solution for this problem. So what could be the optimal solution? How can we get the optimized approach? So can we think about the hashing technique? And 2-pointer. What could be the complexity in case of hashing technique, and what could be the complexity in case of 2-pointer technique? So if you are going to think about these two approaches, then in that case we have to sort our array first. This array should be sorted in ascending order, because it allows us to handle duplicate values and simplifies the process of finding triplets. So that's why we need to sort the array, right? So in that case, if you are thinking about the sorting of array, then the complexity would be n log n. And if you are going through these two approaches, so definitely we require 2 loops. In case of hashing technique as well, we require 2 loops. In case of two pointer technique, we require two loops. One is outer loop. In case of hashing technique, if we think, so we have one for loop I to n, okay, right, and we will have another loop j to n, and we will find one target value minus of nums of I plus nums of j. This will be the target value, and this target value should be checked in hash map. We will have one hash map here. Here we will check. If it is present, then we have to return the triplets. If it is not present, then we have to add the values over here. So this way we have to get the solution with the help of hash map. I have already discussed about the two-sum problem, which is solved by hashing technique and two-pointer technique. The same way we have to solve the three-sum problem. Three-sum problem is actually a variation of two-sum problem. In the two-sum problem as well, we need to do the same thing. But here, in two-sum problem, we have to do only, like we have to sum only two values. But in case of three-sum, we have to sum three values. So in this case, we have to get the triplets. So similar way, we have another problem like four-sum. In that case, we have to find out the quadruplets. The same technique we can apply over the four-sum problem as well. So for the two-sum, for the hashing technique and two-pointer technique, in both the cases, we will get n square log n complexity, time complexity. So here in this case, in these two loops, we will get n square. And for sorting, we will have extra log n. So in this case, n square log n we will have. So for hashing technique, we will have n square log n. If we discuss about the two-pointer technique complexity, so in that case, we have one for loop, outer, and we have our left and right pointers. Two pointers we have, and this should be nums of length minus 1, right? So we have to iterate one extra loop from left to right. So in this case, our complexity is O of n square plus we are doing the sorting, right? In that case, we have a complexity of O of n log n. If you are adding element into the set to avoid duplicacy, in that case, we will have extra overhead. So if we calculating all the complexity, we will get n square log n. So this is the time complexity we have for two-pointer technique as well. So let's go through the solution for hashing technique first. So first we have to sort the array dot sort nums, right? Now have to add one for loop. Now first we have to sort the arrays dot, we can use arrays dot sort nums. Okay, now I will use one outer loop here. Int I is equal to 0, I less than nums of length minus 2 and I plus plus. We have to avoid the duplicate elements. We have already sorted the array, so we can simply skip the duplicate elements if nums of I is equal to nums of I minus 1. If this is the case, we can simply do the continue. and here we will add one inner loop, and it will start from I plus 1, and this should be run from j to length of array j plus plus. Here we will add one element complement, and here we will add this nums of j plus nums of I. Okay, so if this complement is exist into the map, here we should have one count map. We have to create over here integer count map hash map. If it is exist, then we can simply add this. We have to create one list of integer result res new array list. Okay, so here we have to add the arrays dot as list. So we will add these numbers, nums of I, nums of, it should be complement, and nums of j. These are the triplets, and here we have to avoid the duplicate, means second we have to skip the second duplicate, second number. So in this case we have to write j plus 1 less than nums dot length and nums of j is equal to nums of j plus 1. In this case have to in the j plus, right? And if this doesn't exist, then we have to put this nums of j, right? This way we have to add these values into the, we have to add the values into the map. Here we have to add the values into the map, right? And here we can simply return result res. Okay, let me run this solution. Okay, this is a problem. Sorry, this should be res. Index array of bound exception. Okay, so here I'm checking I minus 1, so we have to add the I greater than 0. Okay, I missed that, sorry. Run this. We have to create this map out of this loop. Now let me run this solution. Right, so all the test cases are accepted. Let me submit this. Solution is submitted successfully. The runtime is 622 ms, right? So we are able to solve this problem with the help of map. Let's see the solution with the help of two-pointer technique. Okay, right. Right, so let's understand the two-pointer technique over here. two pointer technique. Okay, right. So let me take same example over here. -1, 0, 1, 2, -1, 4. Right. So this array should be sorted if we are going through the two pointer technique, right? So the array will look like -4, -1, -1, 0, 1, 2. So if you're talking about two pointer approach, we have to define two pointers. Okay, so one will be named as left and the another one will be named as right. So actually we have three pointers. One pointer will be static and these two pointer will be moving. And I'm using two pointer technique, like I'm using two pointer in opposite direction. Okay, so the left will be, so this is the another pointer, I am just calling it as, which will be static. Okay, we'll start from I from 0 to n. Okay, so this is left is what, I plus 1, and right is n minus 1. N is the length of array. Okay, so if you're thinking about let's say let's do the dry run for this example. So here we have I is equal to 0 and left is equal to 1, right is equal to the size of 0, 1, 2, 3, 4, 5. Size of this array is 6. 6 minus 1, 5. Okay, so what is the sum here? Sum is nums of I, nums of left, nums of right. So in this case, if we see, nums of I is equal to -4, nums of left is equal to -1, nums of what, right is equal to 2. So in this case, sum is what? Sum is -4 minus 5. So sum is -3, which is less than 0. So in this case, we have to increment left plus plus. These things I have already discussed in the last in the two pointer technique. So -3 less than 0. So in this case, we have to increment left plus plus. I have already discussed the two pointer technique in the last video. I will add the description. I will add that video into the description box as well. And I will highly recommend you to go through that video first to understand the two pointer technique. Okay. So left plus plus. So here left will be what? 2. So again we will calculate sum. So this should be -4 only. And nums of left is what? So at position 2 we have -1. We have -1. At position right we have still 2. So we have again -3 less than 0. Again left plus plus. So left will become what? 3. So sum will be -4 plus, at 3 position we have 0. At 5th position we have 2. -2 less than 0. So still it is less than 0. Then again we have to what? Increment left plus plus. So left become 4. So sum will be what? This is -4 plus what, num of left is 4. At 4 we have 1, and fifth we have 2, so we'll get -1 is still less than 0. Here we have left will be 5, which is equal to right. So in this case we have to reiterate the loop, right? So I will become 1. Initially it was for I is equal to 0. Now for I is equal to 1 we will do the same process. In this case left will become 2 and right will be same as what, as 5. So if we see the sum values, so at nums of I we have -1, and at nums of 2 we have -1, and at nums of 5 we have 2. So here we will get 0. So in this case we will calculate this triplet, so that the result will be -1, -1 and 2. This is one output. So in this case if we get 0 we will increment the left plus. So in this case we have to calculate again. We have -1 at ith position, and at left will become 3. So 3 at third position we have 0, and at fifth position we have 2. In this case -1, which is less than 0, so we will increment left plus, and left will become, here it was 3, now it will become 4. So again we will calculate sum. Here ith position, at ith position we have -1. At fourth position, nums of left, we have what, 1, and at fifth position we have 2. So in this case this is -1, this is +1, so the sum is 2, which is greater than 0. In this case our right will be reduced. Okay, so the right will become what, it will become from fifth to 4. Now again we will calculate sum. -1, sorry, so -1 plus, right, here at fourth we have what, at nums of left it is 1, and at fourth sorry at I, okay, so if this will become 4, in that case this is equal to left and right. So again we have to reiterate. Okay, so I will become 2. So in this case left will become what, left will become 3, right will be same as 5. So in this case if we calculate sum, so sum at ith index there is -1, and left nums of left is what, 0, and nums of right is 2. So in this case we have 1, which is greater than 0, so we will reduce right of -1. So in this case right will become 4. So now again we will calculate sum is equal to -1 plus, at left position nums of left it is same as 0, and at fourth it should be 1. So in this case we have again what, 0. So we have got the another output here, the sum of these three numbers is equal to 0. So this is another triplet which we can simply store over here. So what is the triplet? -1, and -1 0 1. This is another triplet. Okay, right? So possibly with this example we have these two triplets only. So this will be our final output. If we get any duplicacy, we have to handle that, because our triplet should not be duplicate over here. So for that we can simply either we can use set data structure, so to maintain uniqueness of the triplets, or we can write the logic for that to avoid duplicacy. We can if we use a set data structure, we can direct like this will be more easy. We can simply add these triplets into set data structure. Okay, so let's see the solution. We will handle both the scenario. We will use set data structure as well, and without set data structure as well, we will try to solve the problem. So let's write the code for two-pointer technique. Okay, so yeah, for two-pointer technique we have to sort the array first. I will keep these two lines, and this is also required, this line is also required, this is not required, I'll remove this. And here I have to define the two pointers. Left is equal to I plus 1, and int right is equal to nums of length -1, right? Yeah, and this -2 should be removed, right? And I'll use while loop here. I will use the same template as we have for two-pointer techniques. Here it should start from left to right, and for every problem we for every two-pointer technique and for every two-pointer problems we can simply use this template. Okay, so this is not required. We can use one int some variable over here. This minus is not required. Nums of j, this should be what? Left. Let's put this in the sequence. Nums of left plus nums of right. Okay, so now here we have to check if sum is equal to 0, then we can simply add this nums of I, nums of left, nums of right. And this is this loop is just to avoid the duplicacy. Skip duplicate element, we can say duplicate element. Okay, so here we should change this. We have this left, and nums dot this should be, we have here right, and this one left plus 1. If this is the case, then we have to skip the element. Here again the same case for right. This should be and here we have the same case for third number. Skip duplicate for right, okay. So here we have this left, and this should be less than right minus 1, and here this should be right and right minus 1. Left should be less than right minus 1, and then we have to check this right one, and here this should be right. If we get some, even in this case, if we get some, then right, minus minus, and left plus plus. This is not required. Else if sum greater than 0, so right minus minus, else left plus plus. Okay, let me run this. So let me submit this. Right, so the solution is submitted and it took 46 minutes, right? And for that solution, for hashing technique, we got around 612 ms for execution time. So let's these two lines. Okay, so I'll use set data structure over here. Okay, and this is also not required if you are going to use set data structures. Let's see what is the impact on the complexity. Okay, so I'm just commenting these lines. Okay, and this is also not required. We can simply control X, no problem. Okay, so this should be set and this should be hash set. So I'm just taking extra space. This is not required anyhow. Okay, but I'm just taking this extra space. Okay, so yeah, so here it is fine. We are adding data into the set, and yeah, here we should new array list because its return type is array list, so res, right? Let me run this. Yeah, so this is also accepted, I believe. Yeah, so here we can see this runtime 691 execution time, and so if we see the solution, we have this extra space set, right? We have taken extra space in the previous problem as well. We have taken extra space, right? Like in the form of hash map, right? So if we can avoid this extra space as well here, but in the previous problem in the hashing technique, we cannot avoid extra space as we have chosen hash map. So here we can, in two-pointer technique, we can avoid extra space. So if we are comparing the complexity, then we can, yeah, we can sure two-pointer approach, two-pointer technique will give us a better complexity in terms of space and even time complexity as well. Like if we are comparing simply the time complexity, both hash map and two-pointer technique have same, but in terms of like extra space, we can avoid extra space in case of two-pointer technique. So this is the benefit of two-pointer technique over here, right? So in next video we will discuss about the four-sum problem, and four-sum problem is just a variation of three-sum. As I told, like if we have understanding of two-sum problem, we can simply solve this three-sum problem. We just need to put one extra loop over here, right? For four-sum problem, we just need to put one extra loop over here on the top of this outer loop. In that case, the complexity will be n cube, right? So in the next video, I'll discuss about the four-sum problem as well. See you in the next video. Thank you. Bye bye.